Morning, grade 11s. I just thought of going through some of the rules about rotation, just in case they ask you. Okay, I'll just add to it also with 270 degrees. I know this was just 1 mark, but let's just rather prepare just in case. Please don't mind my voice. I think I'm coming down with a bit of flu. But yeah, anyway, let's get to it. So what are the rules pertaining to 90 degrees clockwise rotation? What do you do there? Okay, so let's say you have your coordinate, your x and y coordinate. The rule for clockwise, remember clockwise is this way. So for clockwise rotation, you will swap the y and the x. Okay, but in this case, the x gets a negative. Okay, so in our scenario here, where we had point -4 and 0, if they wanted a clockwise rotation, it would be 0 and 4. I think I did say that as well. Yeah, it would have been 0 and 4 if it was a clockwise rotation. Okay. I'm just going to put it there. That's the first rule. What about the second rule? Okay, that's the one that we did. If we have 90 degrees anti-clockwise. Okay, so we have anti-clockwise rotation. What would happen there? So if we have our x and y coordinate there, well, the rule with anti-clockwise, or another word for anti-clockwise, is counterclockwise. Counter just means it goes against. So counterclockwise rotation. If you have your coordinate x, y, again, we do swap the x and the y coordinate, okay? But in this case, instead of the x getting a negative, the y gets a negative, okay? And looking at our coordinate here, -4 and 0, we were going to have 0 and -4. I mean, the 0 cannot really get a negative. It's just 0. Now, what happens when we have 180 degrees clockwise? Well, let me tell you this. If you have, think about it. If you have, let me talk about, let me just say a triangle. If I'm going to rotate it 180 degrees clockwise, if it goes in this direction, it would look like this. What if I do it anti-clockwise? So that means I'm going in this direction. It will also look like this. Okay, so what I'm trying to say here is a clockwise rotation as well as a counterclockwise or anti-clockwise. It'll have the same answer. Okay, it's 180 degrees, so it'll have the same answer. So what's the rule there? If you have your coordinate, your xy coordinate, you leave the x and the y coordinate as it is. You don't swap it around, okay? But what happens then? Both the x and the y get a negative onto them, okay? Now let's jump over to 270 clockwise rotation. Okay, so with regard to 270 clockwise rotation, you have your coordinate over there. And then what are the rules? Okay, so you would have y and x. Okay, those are swapped around, but in this case, then y gets a negative. And I hope you see that it's actually clockwise rotation, 270 clockwise rotation is similar to 90 degrees anti-clockwise rotation. I hope you see that. Okay. And then if we have 270 degrees anti-clockwise, rotation, what would happen there? So you have your XY coordinate, but now again, your X and your Y, they swap, and in this case, X gets the negative. So we can see as well that a 90 degrees anti-clockwise rotation is pretty similar to a 90 degrees clockwise rotation. All right, so basically what you really need is the 90 and the 180 degrees. But that's if you can remember which 270 clockwise rotation goes with which 90 degrees anti-clockwise rotation. Okay, so yeah, so just wanted to go over those rules before we head over to trigonometry. Now we're gonna do question 5. Okay guys, please don't forget to like our videos and subscribe to our channel, and please comment below if there's a particular paper that you would like us to cover before exams. But based on the comments, I will see if I can do a paper that a lot of people request, because I cannot do all the papers. We do not have all the time in the world, unfortunately. Okay, cool. So anyway, it says determine the value of the following without the use of a calculator. Okay, before you do trigonometry, please, maybe somewhere for yourself, just draw for yourself the Cartesian plane. All right, just so that you can see what's going on and remind yourself of the cost rule. Okay, so this is all sine, tan, and cos positive. In the second quadrant, only sine. In the third quadrant is tan. In the fourth quadrant is cos. Okay, our maths teacher, back in the days, she used to say, all smokers take cocaine. But I don't think that's true. But here I am, after so many years later, I still remember it. Okay. I don't know what you guys say and how you guys remember it, but yeah. Basically, all smokers take cocaine. There was another one though. Yeah, I forgot. It had to do with strippers, but I forgot. Maybe it wasn't that important. Now remember, in the second quadrant, our rule is 180 minus theta. The first quadrant is theta. For tan, it's 180 plus theta. For cos, it's 360 minus theta. Okay. Oh yes, all strippers take cash. They don't use cards, okay? Or maybe they do, but all of them take cash. Yes, that's the one. Anyway, let's get to the question. So it says, determine the value of the following without the use of a calculator. I'm glad they don't need the calculator because I forgot to load it. Okay, so we have tan 180 minus x multiplied by cos 360 plus x and that's divided by 2 times cos 90 plus x. Okay, so how are we going to deal with it? So tan 180 minus x, I can see that we are in the second quadrant, and I know that tan is negative in that quadrant, okay? So we're basically going to kind of have negative tan x. I'm just going to put that in brackets, especially because of that negative. All right. Then I'm going to move over to cos. So we have 360 plus x. In the fourth quadrant, we have 360 minus the angle. So now 360 plus an angle, it makes us move to the first quadrant. And in the first quadrant, we know that cos is positive. Okay, so therefore I'm just going to write cos x. And then we have 2. Now here, just be careful, guys. If you have a 90, I normally say if you have a cos and a 90, that changes it to a sine. Okay, it's one of those co-ratios. Okay, remember the co-ratio rules? Do you want me to summarize them for you? Okay, so basically if you have sine 90 plus x, and you have sine 90 minus x, cos 90 plus x, cos 90 minus x. Please make sure you do know. Okay, if you have the sine and the 90, changes it to a cos. Okay, cos x. Now 90 plus x, it means 90 plus x, it means we're in the second quadrant, so sine is positive there. Okay, now same thing, sine and 90 changes it to a cos x. Now 90 minus x, we're in the first quadrant, and their sine is positive. So at least you know for sine, you always get a positive cos x. What about cos? Which is what we have, 90 plus x. So cos 90 changes into a sine x. Okay, let's just write there, sine x. But 90 plus x is in the second quadrant, where cos is negative. So therefore, you're going to put a negative there. Okay, that is how you determine the sine, okay, with the negative. Okay, I hope you get that. And then the cos and the 90 turn into a sine. Now, is it positive or negative? 90 minus x is in the first quadrant, and cos is positive there. That's how you determine which sine goes where. So for our question over here, we have a negative sine x. Okay, now let's expand it. In grade 11, the identity that we have, remember we have tan x is equal to sine x over cos x. Another identity that we have, 1 is equal to cos squared x plus sine squared x. If you need to write these down for yourself, please do, so that you do not forget. Okay, and all these identities can be written in different ways. What I mean is, you can write this expression in terms of cos squared x. Okay, 1 minus sine squared x. You can do that in terms of sine squared x. You can also do that in terms of cos x or sine. You can do a lot of things. You can do some gymnastics with this. Okay, that's basically what I'm saying. And that will help you, because sometimes they won't write it exactly as it is. Okay, but if you know you can write it in different ways, you can identify certain things quicker. Now back to our question. I took a little bit of a detour. So minus tan x will be minus sine x over cos x, and I'm multiplying by cos x over 1. Basically, this cos x. Okay, or just cos x, it's okay. And that's divided by negative 2 sine x. Already the negatives will cancel. Negative divided by negative is positive, right? And then I can see that the cos also cancels. The sine will also cancel. And so basically I'm left with 1 over 2. Okay. I hope you got that. And then 5.2, it says given the identity, so we have sine theta minus 2 sine theta cos theta all over 2 cos squared theta plus cos theta minus 1 is equal to negative sine theta over cos theta plus 1. Okay, so we have this identity, and the first question is that we must prove the identity. Now you must choose for yourself. Which one would be easy? To show that the left-hand side is equal to the right-hand side, or to show that the right-hand side is equal to the left-hand side? Okay, if I look at the right-hand side, and I need to work my way to the left-hand side, I don't know where I'm going to start. So I definitely want to look at the left-hand side and see what can happen there. So let's do the left-hand side. Okay, sine theta, I can't do anything about that. So I'm just going to leave it as that. But actually, if I look at the entire sum, I also can't do anything about 2 sine theta cos theta. In grade 12, however, you will learn you can do something about it. But in grade 11, I can't do anything about it. So I will go over and see, do I have a common factor? And yes, I do. I have sine as my common factor. So if I take the sine out, I'll be left with 1 over here. And if I take sine out over there, I'm left with minus 2 cos theta. Okay. And I can also see, as you're doing the identity, keep looking at the right-hand side in this case, because we decided to start with the left-hand side. Keep looking at the right-hand side because we are working towards the right-hand side. So the fact that I've isolated sine, I'm happy about it because I see that sine over there is the answer, one of the part of the answer, let me just say. And now in the denominator, I see we have 2 cos squared theta plus cos theta minus 1. I hope that you can see that this is actually a quadratic equation. Okay, let's just say let cos theta equal to x. If we did that, we would have 2x squared plus x minus 1. Is it easy to see it that way? If you cannot see it through your trigonometric expressions, please use x, use y. Okay, if you are here, you can then factorize, can't you? I hope, yeah, you can see it easily if you use 2 brackets. If you have to use the quadratic formula, you know what? If you're fast enough, I would say do it, just to make sure that you have the answer at the end of the day. But I would suggest using these brackets. So because I have 2x squared, one bracket has to have 2x, another one has to have x in order to get 2x squared. And because I have a 1 there, 1 times 1 will be equal to 1. Now the question is, where does the negative go? I see I have a positive x there. So whichever one I'm multiplying with 2x, like 2x will be multiplied with that one. So I'm going to put a positive in this one, and the negative has to go. So 2x squared, I see that, and I have plus 2x minus x will give me a positive x, and then negative 1 times 1 gives me negative 1. Okay, let me leave that there. So that's how I would have factorized. But remember, we're not dealing with x here, we're dealing with cos theta. So I'm going to go back and say, in the place of x, I'm going to put a cos theta. So I have 2 cos theta minus 1, and I have cos theta plus 1. Okay, remember to put your equal sign there. And then can I simplify? I have my sine theta here, which is there. I have a cos theta plus 1. I see it. So meaning these two have to cancel, but here's the thing. I have 2 cos theta minus 1, and on the top I have 1 minus 2 cos theta. So what I'm going to do here, I'm going to take out this negative outside. Okay, if I take the negative outside, I'm going to have negative sine theta. Then because I took a negative out, this portion here will be positive. 2 cos theta is positive, but the 1 now gets the negative. Okay, if you multiply back the negative, you'll see you're going to have a negative 2 cos theta and a positive 1. All right, so I hope I didn't confuse you there or lose you. So I took out the negative, and then I'm also just going to put this cos theta plus 1 over here because I want my answers to look closer to the right hand side. And then I'm going to put the 2 cos theta minus 1. And things can cancel now. So ultimately I have negative sine theta all over cos theta plus 1. And that is basically equal to the right hand side. And we are done with this identity. Aren't you happy? Okay, cool. Now 5.2. It says, for which values of theta will the identity be undefined? All right, so in this case, you can look at the left-hand side part of the equation or the right-hand side. And both of them are fractions, which is good. I'm going to look at the easy one, which is the right-hand side. Okay, where we have negative sine theta all over cos theta plus 1. Okay, now how will this be undefined? Which values of theta will be undefined? Basically, if your denominator is equal to 0, then if you were to just put denominator equal to 0, any number, 7 divided by 0, you'll get a math error. Okay, complex infinity. But in your calculator, you will get a math error. Okay, so basically that's what we're looking for. So we're going to make our denominator equal to 0. And that is how we will get values that will make the identity to be undefined. All right, so basically then we say cos theta is equal to -1. Now how do we get our reference angle? Reference angle. So there are two ways of doing it. I like asking my students. I have two ways of solving this. The one way is when we're getting our reference angle is to say theta arc cos, we include the -1. Okay, and when we include the -1, whatever answer that we get, we will use this answer, and then in order to get the general solution, I hope that you realize here, this is 5 marks, we need to get the general solution, because through the general solution, we can get more than one answer, where we have theta giving us or making the identity undefined. That's what we want. If they had given us a domain to say between the values of 0 and 180 degrees, where will theta be undefined? Maybe you can get one answer and can solve it. But if there isn't any domain or restriction to a domain, you need to look for all the answers. Therefore, a general solution must be used. Okay, so the first option is you include the negative as you're getting your reference angle. Okay. And what does that mean? It means for a general solution, you will always consider the quadrants where cos is positive, which is quadrant 1 and quadrant 4. The second way of doing it is when you get the angle, you only take the positive of this answer, which is 1. And then this negative, you ask yourself, so you're going to get your reference angle. You ask yourself, where is cos negative? That's how you then factor in the negative. And cos is negative in quadrant 2 and quadrant 3. I don't know which way you prefer, but most of my students prefer this way. So I'll use that. Okay, so in order for us to get the reference angle, I will then say theta is equal to arc cos 1, and if you're to sketch the graph of cos, let me do it. I'm taking time here so that you understand. Now that you are at home, you can watch, you can forward, you can rewind, and all those things. Okay, there at the exam prep, we were limited for time, so we couldn't do everything. Okay, so with a cos graph, you start there at 0 degrees, then 90, then -1, 270, there we go, and same thing here. So a cos graph looks like this. So just by sketching it, you can see where will cos be equal to 1? Well, at 0 degrees, at 360 degrees, at, if I continue, probably 720 degrees. So it goes in multiples of 360. We're also getting it at -360 degrees. So you get the drill. And it doesn't end there because we were not limited. Our domain was not limited. But let's see. So if I say shift cos 1, I get 0. So my reference angle is basically 0 degrees. All right, now let us get the general solution. So we said if we're going with that, where is cos negative? In the second quadrant and the third quadrant. In the second quadrant, we know that we have 180 minus our reference angle, which is 0 degrees, and the period of the cos graph is 360. And then we have to say times k, where k is an element of integers. So if we just simplify that, we have that theta is 180 plus 360 degrees times k. So that is our general solution. If we're looking at quadrant 3, we're really going to get the same answer, but let's have a look. So we have theta. In quadrant 3, we have 180 plus 0 degrees. And again, we have 360 times k, or k times 360, however we prefer to write it. So basically, theta is 180 plus 360 times k. Okay, and that's basically that. And now we get to question number 6. Okay. So yeah, let's have a look at that. All right, question 6.1. So it says if negative 3 sine beta minus 2 is equal to 0, and beta is an element. So basically, the domain is from 0 degrees to 270 degrees. Okay, let's just sketch our Cartesian plane again. Okay, so it goes all the way from 0, so it's applicable in these 3 quadrants. All right. Sorry. Use a sketch in the correct quadrant to determine the value of 1 plus tan squared beta without a calculator. Okay, so we have negative 3 sine beta minus 2 is equal to 0. So I'm going to take the negative 2 to the right hand side. And it becomes 2, right? And then I'm going to divide by negative 3 so that I can get sine beta alone. So we have negative 2 over 3. And remember, sine is opposite over hypotenuse, right? So, like soccer tour. So yeah. Or you could say negative 2, okay, we have y over r. R wouldn't really be a negative, it's a hypotenuse. So our y value is negative 2. So where is y negative? It's negative in this region here. Okay, so basically the negative 2 will be somewhere there. Okay. So if we were to put now a line, it would have an x coordinate and a negative 2. And then the r would be 3. Okay, so we can go and work out what x is, because I can see already in the question they're asking about 1 plus tan squared beta, and tan is opposite over adjacent. So I think it would be best for us to determine the value of x. Okay, so here we simply just use Pythagoras, and Pythagoras says r squared is equal to x squared plus y squared. Okay, in this case r squared is 3, r squared is 3 squared, x is what we're looking for, and y is negative 2 squared. Okay, so if we are looking for x squared, it'll basically be 3 squared is 9, and if I take this to the other side, it's going to be minus. So negative 2 squared, that is 4. If it goes to the other side, it's minus 4. Okay, so 9 minus 4 is basically 5, right? And we're going to square both sides. Now, here's the thing. When you square both sides, you can either have a positive or a negative answer. And looking at where we have drawn our line, the x, the possible x value will be negative. Okay, so when you are looking for x, please do not say x is positive root 5. It will actually be negative root 5 because on the negative side of the x-axis. So yeah, so if I were to use a different colored pen, this would be negative 2, that would be negative root 5. Okay, so now that we have the value of x and y, I think we can go ahead and determine what 1 plus tan squared b is. Oh, by the way, where is beta? Okay, beta will be over here. All right. Now let's go and solve for 1 plus tan squared beta. Okay, and basically that will be equal to 1 plus, we know that the identity of tan is sine over cos, or actually you don't even need that, let's not complicate life for ourselves. We have our triangle. Okay, we know what the value, we know that tan squared is, or tan rather, is opposite over adjacent, which is basically y over x. So we don't really need to go and say sine squared over cos squared. It's just going to take a long time. So what is the value of y in this case? The value of y is negative 2. And the value of x is negative root 5. Okay? And these values are squared. All right. They said without the use of a calculator. Okay, just making sure. So in our numerator, negative 2 squared is 4. In our denominator, negative root 5 squared will be 5. Okay, and if I have the common denominator of 5, I know I'm gonna need 5, and then I have 4. So basically my answer is 9 over 5. All right, I hope you understood that. If there's anything that's uncertain, please do comment below, and I'll try to explain again in the comment section. Now 6.2. Now it says, if cos 75 is equal to m, express each of the following in terms of m, showing all your working. These questions, I like them, okay, because as soon as they say cos 75 is equal to m, please just, you have to sketch a triangle, okay, a right angle triangle. Now we know that cos is adjacent over hypotenuse. So for yourself there, just put m over 1 so that you know that your hypotenuse or your r value is actually 1. So you have 1 over there. And if this is 75, adjacent would be over here. So now we can look for y. And we know that if I use Pythagoras theorem, we know that y squared is equal to r squared minus x squared. And r squared is 1 squared, which is just 1. And x squared is m squared. Okay, so y would be root 1 minus m squared. Now, I'm sure you're asking, are we going to use positive or negative? In this case, take the positive value, okay, because they haven't given us a quadrant to work in. But actually, the fact that it's cos 75 means it's in the first quadrant, and in the first quadrant, everything is positive. Okay, all of them are positive. Okay, so you can be rest assured that we're dealing with positive y and not the negative version. So we have 1 minus m squared, the square root of 1 minus m squared. Okay, and if you wanted to, the angles in a triangle are equal to, the sum of angles in a triangle are equal to 180. So 75 plus 15 actually will give you 90 degrees. 90 degrees plus 90 will give you 180. That's if you just wanted it there. Now let's go and answer the question. So 6.2.1, they say express each of the following terms in terms of m and show all your working. And we're getting 2 marks here. So cos squared 105 degrees. Okay, or rather we can say cos 105 squared. We can write it like this. For those of you who didn't know, you can also put it like that. It might make matters a bit easy. Now we have an angle that is bigger than an acute angle. I would suggest at this point, please reduce your angle. Remember, in the second quadrant, we have 180 minus theta. We have 180 plus theta. And in the fourth quadrant, 360 minus theta. In the first quadrant, we just have theta. So if I look at 105, I know it's in the second quadrant. And I know that cos is negative in the second quadrant. So I have negative cos. Now my question is, if I say 180, what do I need to subtract in order to get 105? I need to subtract 75, right? So if I say 180 minus 75, I will get 105. And remember, all of this is squared. Okay? So, yes, we have, let me put it like this before I even put the negative now. Yes, this is how I can rewrite it. So cos 105 is cos 180 minus 75. And then I know that this 180 minus theta is in the second quadrant where cos is negative. So then I have negative cos 75. And remember, all of that is squared. And what is cos 75? It's basically m. So I have negative m squared. And then my answer simply becomes m squared. All right. I'm surprised they gave 2 marks for it. I would have thought they would give more. But yeah. And then we have sine 15. And that helps because in our triangle, we do have 15 degrees. And what does sine say? It says opposite. What is the opposite of this 15? That's m. Opposite over hypotenuse. M over 1. Okay. So we can see that's m over 1, which is simply m. Okay, and I hope that you see that sine 15 is actually equal to cos 75. And why is that? They are co-ratios. Okay, for those who didn't put the 15 degrees, they would have realized actually sine 15, if I say 90 minus 75, I get 15 degrees. But yeah, anyway, the last one, 6.2.3, tan 15 degrees. Okay, again, we have our right angle triangle. Let's use a different color pen. So tan 15, so remember we are looking now from this point. Tan is opposite, which is m, over adjacent, which is root 1 minus m squared. Okay, so basically we're going to have our answer there. Opposite, which is m, all over adjacent, which is 1 minus m squared. Okay, that's good enough. That's good enough. And yeah, that's it with the trigonometry section. And we did cover this in on Saturday, but let's do it again. Okay, for those who didn't really understand Euclidean, let's give it another try. Okay, so we have question 5.2. Now it says A, B, C, D, E are points on the circle having center O. Okay, so we can see there's A, B, C, D, E. Okay, and they have a center O. For me, when I think, remember when I said, as soon as I hear center, I start thinking line from a center to a chord is, it bisects the chord and it's also perpendicular to the chord. When I hear center, I think angle at the center is twice the angle at the circumference. Okay, and I look there, do we have an angle at the center, angle at circumference? Not really, so that's fine. when I think about the center, I think about the radius. Okay, we have a radius. If there's also another radius that's given, I know that I have, what do you call this, an isosceles triangle. Okay, we don't really have that. I also think about the diameter. Okay, because from the center, twice the radius is the diameter, and with the diameter, I think the angle subtended by the diameter is always 90 degrees. Even if it's a smaller than an angle there, it's also going to be 90 degrees. Okay, so those are things that come into mind when I hear center. Okay, and yeah. So then it says DC is produced to G. So it means if I extend this line DC still on it, okay, then it goes all the way to G. And that also gets me excited because I also have a look here. I have a cyclic quad. Okay, and if I have a cyclic quad, by the way, this process I'm talking about, it happens quickly in my mind. It's not like I'm going to spend 10 minutes thinking about this. Because of continuous practice, it comes quickly in my mind. Okay, this happens in a space of a minute. Okay, so, and the thing about maths is you need to time yourself. In most cases, your questions are, your paper is out of 150 and you are given 3 hours. 3 hours, if we divide that in minutes, so, or rather, yeah, if we put that in minutes, you have 180 minutes divided by 150 marks. So for each mark, you should be spending a minute, 1.2 minutes, okay, for each mark. So for me, this thing happens in a space of a minute. I'm taking time to discuss it now, but it happens quickly for me through practice. So practice, 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 and time yourself when you're preparing for exams. So when I think of a cyclic quad, by the way, for it to be a cyclic quad, you need all corners of the quadrilateral to be on the circumference. If they are not on a circumference, it is not a cyclic quad. Okay, good. When I think cyclic quad, 3 things come to mind. Firstly, I'm thinking of an external angle of a triangle is equal to the interior opposite angle. Then I'm thinking the opposite angles in a cyclic quad are supplementary, meaning when I add them up, they're equal to 180 degrees. Okay, they're supplementary. Another thing that comes to mind is from the same chord, angles subtended by the same chord are equal. Okay, so I see I have a cyclic quad and I see I have an external angle. Maybe let me use a highlighter instead of this pen. Okay, in this cyclic quad I have an external angle. So that's great. I can use that. And I also have angles being subtended by the same chord. Do I have it? No. If I look at chord CD, it only goes to E1. If I have a look at chord DE, okay, not within this cyclic quad, but if I have a look at chord, yeah, okay, let's just focus on the, yes, actually, if I have a look at chord, if I look at chord BE, okay, there I have D2 that comes from BE, and I also have C2, okay, so at least I have something like that as well. And I will always have angles that are opposite that are supplementary. Okay, if I have B, then I have D1 and D2. And if I have E1 and E2, I have C2 and C3. Okay, so that is applicable. Cool. And then what else do they tell us? They tell us that diameter AOD, okay, we spoke about diameter. There we go. It bisects chord CE. So we have an angle from the center to the chord, okay, which ends up bisecting the chord and is also perpendicular to the chord. And they tell us that we have a diameter. So if I have a diameter over there, I get excited as well because I know the angle subtended by a diameter. So I have diameter AD, it subtends E, so that is 90 degrees. Okay, and then it intersects chord BE at S. Okay, cool. And we have A, which is 32 degrees, and CGB, which is 70 degrees. Okay, that's good enough. Now let's go ahead and answer these questions, right? I rushed through it on Saturday because of limited time, but here you are. You can fast forward, you can rewind and all of that. Okay. So it says, calculate with reasons the sizes of the following angles. So we're looking for E, angle E at BED. So where's B? There's B. There's B. There's E. There's D. So we are looking really, I think we've talked about this, né? So we can erase it a bit and then we'll go back to it. And with Euclidean, you need colored pens. So yeah, but it can get a bit messy eventually. I have the advantage of erasing. So I'm looking for angle E1 and E2. Okay, and remember, I know that I have a cyclic quad BCDE. And I see that I have an external angle in a cyclic quad. So basically BED will be equal to 70 degrees. Why? Because the external angle in a cyclic quad is equal to the interior opposite angle. Okay, but we can just say exterior angle of cyclic quad. And I would advise that every time you get an angle, just also indicate it on your sketch, okay, so that you can populate it and see what's missing. All right, let's move on. Now we're looking for, so 5.2.2, we're looking for C2. All right, now let's go have a look where C2 is. So this is where C2 is. All right. Yeah, and also the mark allocation will guide you. So we have 4 marks over there. So we're going to do some bit of work. So what we do know is that C1 is 70 degrees. C2 is what we're looking for. Do we know what C3 is? Let's think about it. So if you look at chord DE, let me just erase that and start with C3. If you look at chord DE, it has subtended the angle C3 and it also subtends the angle A. Okay, if you don't know how to get the angle that is being subtended, put one finger at D and another finger at E and use those 2 fingers to go along these lines. Okay, and you can see, oh, there it goes, it subtends C3. Again, look at other lines or look for other lines that start from D and start from E, and you can see it goes all the way to A. All right, so then we can say C3 is actually equal to A, which is equal to 32 degrees. And why is that? It's because the angles that are subtended by the same chord are actually equal. But on your side, I think you're not going to write all of that down. So what you would write is angles in the same chord. I would advise you that if you forget this reasoning, this shortened reason, write a paragraph if you have to, just to ensure that you have those marks. Okay, so angles in the same segment. Okay, it's an easy enough reason to remember, but like I said, for me, angles subtended by the same chord are equal, or angles in the same segment. Okay, so now we have 32 degrees. All right, let me just remove that for now. So I have C3, it's 32. Now I can go and say C1 plus C2 plus C3 is actually equal to 180 degrees, okay? And that's angles in a straight line, or the sum of angles in a straight line are equal to 180 degrees. Or you could just say angles on a straight line. All right, now we're going to write everything in terms of C2 because that is what we are looking for. So we're going to say C2 is equal to 180 minus C1 minus C3. Do not forget the caps on top of the C's. Okay, these cappies. Okay, and we know what C1 is. It's 70 degrees. We also know what C3 is. It's 32 degrees. Okay, and then we can just simply use our calculator. So we have 180. We have 180 minus 70 minus 32 is 78 degrees. Okay, if you have other ways of solving it, please do share with us. Remember, there was another lady who got it a different way, found the answer in a different way. I'm not going to divulge much into that, but it had to do with supplementary angles. So if you have 70 degrees here, you would have 110 degrees there. Okay, and yeah, actually, well, I'm already at it, so let me just give you that other option. So I would know that E1 plus E2, if I added with C2 plus C3, I would get 180 degrees, okay? So basically opposite angles in cyclic quad are supplementary. Okay, so E1 plus E2, that's just 70 degrees. Okay, and we have C2 plus C3. We already, by that time, we would have C3, right? So we have C2 plus C3, which is 32, and that's equal to 180. So if I take the 70 to the other side, I know that C2 plus 32 is 110 degrees. And if I just say C2, we say 110 110 minus 32, we get 78. So if you have any other way of determining it, please do comment for the other learners to learn from you. All right, now D1, which is 5.2.3. Where is D1? Okay, like I said, if you find something, just write it down. So C2, we have it. It's 78 degrees. Now we're looking for D1, which is, use a different colored pen. Let's go with red. Here is D1. Now, remember, we said angles from a line from the center to a chord bisects the chord, and it is also perpendicular to the chord. So we can then say F2 is equal F2 is basically equal to 90 degrees. Okay, and how did we get there? Basically, the line from center, I don't know if you hate to say center, but yeah, line from center, it bisects the chord, right? So it's a line from the center to the midpoint of that chord. Line from center to midpoint of chord CE. Okay, that's C. All right, so then we know that F2 is equal to 90 degrees. Okay, now in this triangle, Sorry guys, I'm just with my daughter here. So we have D, we have F, and we have C. So we already know that C is 32 degrees, F is 90 degrees, so we can get D1. Okay, so I'm just going to say D1 plus C3 plus F, that's equal to 180 degrees. So basically that's sum of angles in a triangle equal to 180 degrees. So then in order to get D1, I would say 180 minus C3, remember C3 is 32 degrees, minus F, which is 90 degrees. So we can then calculate that quickly. Have 180 minus 32 minus 90, and we get D1 is 58 degrees. Okay, and then E3, so 5.2.4. We have E3. So like I said, if you have an angle, just populate it so that we know what we have. So D1, 58 degrees. Where is E3? E3 is this small triangle over there. And remember, we know that angle subtended by the diameter is actually 90 degrees. So let's start there. So we know that E1, or the entire E, E is equal to 90 degrees. Okay, and I would write there, angle subtended by diameter is 90 degrees, but I think you've been taught to say angle in a semicircle. Okay, now we can then say E1 plus E2 plus E3 is equal to 90. I have E1 and E2, which is 70 degrees. I hope I wrote it like that there. Yeah, so basically you can say E1 plus E2. Or instead of saying E1 plus E2, you could say BED. Yeah, rather BED. So I know that E3 is equal to 90 degrees minus BED, which is basically 70 degrees. And then there we are, we get 20 degrees. Okay, and then we are done with this portion of Euclidean. Now we get to a portion that slightly looks a bit challenging, but nothing to be scared of. Please do not let Euclidean geometry intimidate you like that. So it says, refer to the diagram below. All right. Sorry guys, I'm just checking time. I need to go to work. So yeah, refer to the diagram below. ST is a diameter. Again, we get excited. ST is a diameter. Which angle is subtended by this diameter? It is U1. Okay. So somewhere there on your paper, you can write that U1 is equal to 90 degrees. Angle in semicircle. Okay. Okay, then it says OS is parallel to PN. Okay, there is OS and it's parallel to PN. Guys, when I hear parallel lines, I get excited. Why? I think of fun. Okay, I go and I have a look. Do I have corresponding angles? Do I? So I have this line. If I were to sketch over here, I see F. Okay, so S1 and S2 will be equal to N over there. I'm just going to leave it like that. Then I think of co-interior angles. Okay, remember co-interior angles are supplementary. Do I have co-interior angles again? So it's this S1 plus S2 plus N is equal to 180 degrees. Okay, I don't really have a value for N. And then I think about alternating angles. Let me use a different colored pen there. Alternating angles, so I'm looking for that Z or that N. Okay, so I know that this little N over here is equal to that O over there. Okay, so those are the alternating angles. All right, now it looks like a mess. Yeah, so let me just maybe write that out for myself. So the S1 plus S2, that is equal to the N, and basically those corresponding angles. Then I said S1 plus S2 plus a different kind of the N. Let me rather, instead of N, let me say O, PNK. Yeah, PNK, so that we know which N comes from there. And then with the co-interior, I should say SNP. Okay, so that's equal to 180 degrees, and that's co-interior. And then with the alternating angles, I would say O is equal to ONP. Okay, and that is alternating angles. Then I can at least erase here so that I can see what's going on, or else everything's just going to be a mess. And remember, guys, what I said previously, what I just wrote, that is what I would do in a minute, okay, because I've practiced this a lot of times. And then it says TO bisects STP. So there's TO. It bisects the angle T, STP. So it bisects this angle over here. And they tell us that T1 is actually X. Okay, so if T1 is X and they tell us that TO bisects T, we know that T2 is also X. Okay, and that was given. All right, so everything that I've said, we've had a look at. Now let us answer the questions. 10.3.1. They say, prove that punk, P-U-N-K, is a cyclic quad. If you want to prove that something is a cyclic quad, remember what I said about cyclic quads? There are three things to think about whenever you hear cyclic quad. Either you can prove it either by showing that the external angle in a cyclic quad is equal to the interior opposite angles, or you can prove it by saying opposite angles in a cyclic quad are supplementary, or you can prove that angles that are coming from the same segment or angles subtended by the same chord are equal. Okay, we don't have to prove all three. Just one of them is enough. Now let's see. P, let's just take that apart. So we have P. Where's P? There's P. U, N, K. So imagine there's a circle around there. That's what you need to do to answer this question. It helps to actually draw something out so that you can actually, for those who are visual learners. I am a visual learner myself, so I need to see something. I need to see that circle for me to imagine that it's there. All right, so let's see. For the three options that we have, let me just sketch them quickly. Which one would be applicable? Okay, let's see. If I have this as my cyclic quad, okay, can I use angles from the same segment? I can. If I were to use, actually all four of them, it's a possibility, but it's to prove that angle, it's going to take me a while. All right, and then if I were to, remember, this is 90 degrees, no? So that's 90 degrees. It means that U3 plus U2 is also 90 degrees. Oh, so actually, I can also use the exterior angle in a cyclic quad, okay, which is that U1, which is 90 degrees, is equal to the interior opposite angle. Okay, so I will have to prove that K2 and K3 are actually equal to 90 degrees. That's one option. So I need to just look at that closely again and see, can I show that that's 90 degrees? So I can use this exterior angle. And then opposite interior angles are supplementary. Oh, that might be a difficult one to prove as well. Okay, so let's see. Okay, guys, I'm seeing something else. Yeah, I'm seeing something else. Remember, TS is a diameter, and we have that 90 degrees. There's also another angle that's subtended by the diameter, which is K1. I didn't see it. So if you put your fingers on S and put it on T, you'll go to U1. You'll also go to K1. So I think I will go with this option over here, right, of exterior angle in a triangle. And let me show you why. So first, let's start with U1. So I know that U1 is equal to 90 degrees, all right? And that's because the angle subtended by a diameter is equal to 90 degrees. But like I said, we can say angle in a semicircle. Okay, at the same time, I know that K1 is also equal to 90 degrees, and that's also the same reason, okay? Angle in semicircle. So there we go. And then I know that U2 plus U3, that's equal to 90 degrees. Or I could, instead of saying U2 plus U3, I can say PUN. Okay, PUN is equal to 90 degrees. Okay, and that's basically angles in a straight line. Okay, let me just rather say PUN plus U1 is equal to 180 degrees. So angles, sum of angles in a straight line equal to 180. And therefore I can say that PUN is basically equal to 90 degrees because U1 is 90 degrees. Okay, and then if I then look at my cyclic quad, remember this is how my cyclic quad looks if I just draw it in isolation. That's where I have P, that's where I have K, N, and U. So basically I know this is 90 degrees. Now I need to prove and show that K3 and K2 or NKP is actually equal to 90 degrees. So because I said K1 is 90 degrees, I know that K1 plus PKN is equal to 180 degrees. Again, angles on a straight line. Okay, so therefore PKN is equal to 180 minus 90, which is 90 degrees. Okay, so then I can go ahead and say, I can either say opposite angles are supplementary, or I could say external angle in a cyclic quad is equal to the interior opposite angle. So it's really up to you which one you use, but I wanted to go the external angle route, right? So I can then say U1 is equal to PKN, which is 90 degrees, and that is because of external angle in a cyclic quad external angle in a cyclic quad is equal to interior opposite angle. All right, therefore, no, before we even get there, I'm trying to prove that this is a cyclic quad. So because U1 is equal to PKN is equal to 90, therefore we can say that PUNK punk is a cyclic quad. And why is that? That is because of the external angle in a cyclic quad. That's how you write that. Or you could have said NUP or PUN is equal to PKN. Oh, no. PUN plus PKN. Yeah, I'd just rather say that. Or you could say PUN plus PKN is equal to 180 degrees. Therefore, PUNK is a cyclic quad. And the reason is opposite angles in a cyclic quad are supplementary. Okay. And that's that for 10.3.1. Now we can go to 10.3.2. By the way, I'm still waiting for your comment. Do you want me to do question 1 while we're at it? So please just tell me below. Otherwise, I would assume that you guys are good with algebra. Okay, so it says, also, so they tell us that SO, well, we're still prove that SO is a tangent to circle at circle cast. Okay, let's just erase everything there so that we can look at this with fresh eyes. I'm sorry guys, I don't know in an exam what you're going to do after you've marked everything. Or maybe just rather use a pencil. Okay, so wow. So SO, there's SO. SO is a tangent to circle cast. So we have, okay. I mean, SO is already a tangent. And whenever you see a tangent, please, something should scream at you, tan chord theorem. So let's say, imagine that we have a circle here. Actually, we already have this circle. This is the circle that we have already. Okay. Okay. Yeah. So we need to what? Prove. Yeah, this question is incomplete. SO is a tangent to circle cast. Okay, so what? I guess we need to prove that SO is a tangent. Okay, we need to basically prove the tan chord theorem. So what does the tan chord theorem say? Basically, if you have a tangent to a circle, what I would say, look for a triangle. If you can find a triangle, that would be perfect, because this angle over here would be equal to the interior opposite angle. And that angle over there will be equal to the interior opposite angle. So that's what you're looking for, basically. Now, if I look at the circle cast, do I have a triangle? I have two triangles, actually, that I can consider. I see this triangle over here, which I think I might work with because I have that 90 degrees. Okay, U1 is 90 degrees. So then I need to show that this side, I also have 90 degrees. And I think that's doable, honestly. If I were to look at the other side, I would have to prove, let me use a different colored pen. I would have to prove that S1 is actually equal to X. Okay, that's also another way of proving it, but now I saw it an easy way. I've already seen an easy way. So I know that U1, let me start with the first one, then we'll look at the other one. We'll look for something. So I know that U1 is 90 degrees, okay? And I've proved that before. Or if you don't want to say you proved, you could just say it's because of TS being the diameter. Okay, so angles in a semicircle. And then I also need to show that this S is 90 degrees. All right. And so I would say then QS, but remember, a line from the center to a chord. Actually, this QS is actually the radius. Okay. And I know that the radius, I know it's a rule. The radius is always perpendicular to a tangent. Therefore, QS, yeah, what do I name this angle? That's the thing. Maybe let's name it beta according to the sketch. So therefore, beta according to sketch is equal to 90 degrees. Okay. So now I would say therefore with U1 being equal to beta, we can then say SO is a tangent. Okay, this one is a little bit tricky because we didn't really have a definition for that angle there is. Okay, so maybe they are forcing us to somehow look at X, and now we need to show that S1 is actually equal to X. Okay, so they've told us that T1 is X, right? That was given. Let's just say O. Okay, we know that T1 is equal to X. Okay, that's given. And T2 is equal to T1, which is equal to X. Okay, that was given because it bisects. So what can we do with that information? If the two are actually, yeah. So that's X. So what can we do with that information? We have another triangle. There it is. Okay. So maybe if we can show that this entire thing, S1 plus S2, is either 2X, or we can stick to our original triangle and show that S1 is equal to X. All right, let's see where this takes us. And then we can take it from there. What can we see? So I know I've called US. So if T1 is X, K2 can also be X. I just want to see what this is going to lead. Okay. K2 is equal to X. Angles in the same segment. Okay. And then what else can we see? We have remember this is a cyclic quad. Please don't forget we already proved it the cyclic quad. So if K2 is X, P1 is X. Okay, but so what? I'm just writing this as I go. So P1 is equal to X. Again, because we know that it's a cyclic quad, but it's also the same reasons, angles in same segment. The same segment, UN. I feel like at this point I need to differentiate which segment we're talking about. So even K2 being equal to X, it's from segment US. Okay, so we have x there, we have x over here. Now what can we say? Remember we have parallel lines. Let me just use a different colored pen. Maybe parallel lines can come into play. So there we have the parallel lines. Okay, or maybe I can use that. Oh, yes. We have alternating angles. Ooh, we had to go all that way to prove that S1 is equal to P1, which is equal to X. And that's because of alternating angles. And whenever you write the reason alternating angles, you must say which lines are actually parallel. Okay, so because we've been told OS is parallel to PN. Sure, so now we can see that S1 is equal to X. So therefore, because S1 is equal to X, because we're still gonna look at this big triangle over here, and we know that T1 is equal to X. S1 is X, T1 is X, therefore OS is tangent. Yo, this was way longer than my originally preferred way of solving it. How many marks was this, by the way? 6. Okay, I get it. 6 marks. So yeah, guys, I think I would rather go with this one. But you know what? In maths, if you can still find the answer and you can prove it, you can write down an answer in 1 or 2 lines and get the 6 marks. Or you can write 1, 2, 3, 4, 5 lines and get 6 marks. As long as you can show how you got it, that would be great. Okay, last question. Or is it? Yes, it is. So it says 10.3.3, prove that post is a cyclic quad. Jeez. By the way, whatever you have proved, do not forget it. Okay? And this is what I mean. We're just going to write down everything that we have shown and everything we have proved. We know that this is a cyclic quad. Don't forget it. Okay? We know that here we can use the tangent to show the tan chord theorem. Okay? So, yeah. By the way, I forgot to say here, it's tangent because of the tan chord theorem. Okay. Now let's go to 10.3.3. It says prove that post. So where is post? We have P of O S T. Yeah, no, Euclidean will make you work. So we need to show that this is a cyclic quad. So imagine there's a circle around it. Okay. So we can either show that NOS is equal to PST, or rather SPT or TPS. Okay. What else can we show? Is the an exterior angle in a cyclic quad? Yes, there is. I mean, there's this 90 degrees over here. If we can show that actually TPS is 90 degrees, that would also be great. Okay. So if we can show, yeah. So this would be angles in the same segment, right? That's one way of proving. Second way of proving is if we can show that S is equal to TPS, which is equal to 90. That would be the exterior angle in cyclic quad. That would be the second way of showing. The third way of showing is to show that S1 plus S2, which is 90 degrees, plus, okay, let me stop writing S1 plus S2. Let me rather say TSO. I need to show that TSO plus TPO is actually equal to 180 degrees. So basically showing that angles are supplementary. Opposite angles in a cyclic quad, supplementary. Those are 3 ways I can show. Okay, how many marks is this? 3 marks. All right, so let's see then which one we can actually use. Okay, and let's write down everything that we know. We know that T1 is X, we know that T2 is X, we know that S1 is X. What else was X? K2 is X. P1 is X. What else? Yeah, so those are all the X's. Okay, so now if I can, what would T2 or S2 be? S2 would also be X, but do I need it? Okay, let's see what we can show there. Actually, guys, I might have a different way to everything that I've written here. Now that I've put all the X's, what I'm seeing is, so I have ooh, yeah, we're all sick in this house. So yeah, so I have S1 there, which is X, which is, this is why it's so important to keep writing all the information that you have, because you don't know how you're going to end up using it. So these two, I'm seeing that T2, which is equal to X. I've already shown it and proved it. And I see that S1 is equal to X, which I have already proved. And if I track which chord they are coming from, they are both coming from chord PO. I hope that you see. They're coming from chord PO. So in this mess over here, you can see what's actually happening. Okay, so because of that, because T2 is equal to S1, which is equal to X, we can say that POST is a cyclic quad. Okay, and why is that? That is because we have, okay, we did it in normally you'd say the chord subtends, right, the same angles, and then you write the angles in the same segment, but now we're doing it the other way around. So basically it is the converse of angles in the same segment. Okay, and that's it. And we're done with this paper. Please do let me know. Like I said, I'm not going to do question 1 unless if you guys ask. All right? And I need to go to work. Bye.